Hi, I'm Vishal Karthik, a senior software developer. I'm thrilled to showcase my latest project, an advanced portfolio analysis application. This tool highlights the power of AI assisted development, blending Cursor.ai and Claude 3.5 to bring financial analytics to life. Let's dive into how AI can transform coding into an efficient and creative process. The essence of this project is leveraging AI to simplify and enhance development. AI tools not only accelerate tasks but also improve code quality and developer satisfaction. Let's explore these benefits before we dive into the code base. Developers using AI tools like GitHub Copilot have been shown to complete tasks up to 55% faster, significantly decreasing development timelines. AI assistants help reduce errors by providing real time code suggestions and automated debugging, leading to more reliable and maintainable code bases. Around 60 to 75% of developers feel more fulfilled and less frustrated when using AI coding assistants since they handle all the repetitive tasks, allowing them to focus on more creative aspects of their work. They can also assist less experienced developers or newcomers understand complex code bases, thereby accelerating their onboarding process. AI can also automate the generation of code documentation, ensuring consistency while saving them time. Now let's dive into the heart of the project, the code base. I'll walk you through each module, showing how everything comes together to create this powerful portfolio analysis tool. Fetching historical stock data is the first step. In this project, I'm gonna use Y Finance to fetch the stock data. The function fetch stock data downloads stock data uh, for the tickers in the portfolio over a specific date range. Then it returns a dictionary with historical data frames for each stock ticker. Cursor helped me find the correct library, the Y Finance library I talked about. It also helped me with API errors and missing data. Now with this fetched raw data, the next step is to clean and process it. The process stock data function does the cleaning. It's not much, I'm just dropping entries with missing values, but the modularization helps make room for future pre-processing. Then we'll move on to calculate the key portfolio metrics. The calculate portfolio returns function computes daily portfolio returns based on stock weights. This metric forms a foundation for analyzing overall portfolio performance. And this function calculates the annualized volatility of portfolio returns, also called as standard deviation. And volatility is a measure of risk. It measures how much the portfolio returns fluctuate over time. This one calculates the portfolio returns risk adjusted return actually. A higher Sharpe ratio indicates more efficient portfolio, balancing return and risk. Beta calculates how much the portfolio values change in response to market movements. VAR is value at risk. It represents the maximum expected loss under normal market conditions. And this function right here runs the Monte Carlo simulation. It runs simulations to forecast future performance, providing a probabilistic view of future possible outcomes, helping assess risk tolerance and all. This one aggregates key statistics from functions we discussed before, like a summary generator. And this one's a helper function, so don't mind that. This is the optimize portfolio function, which identifies optimal portfolio weights for a given return or risk level. It helps us identify the best allocation of assets to achieve a balance between risk and return. And the last one right here generates point along the efficient frontier by optimizing portfolios for various levels of expected return. So in all these, Cursor helped me with the formulas to calculate metrics, helping me debug matrix operations for Monte Carlo simulations, saving me a lot of time. And it recommended the sci-fi optimized library, I think, and it prevented me from writing the entire function manually. So now to make sense of the metrics and the simulations, we visualize the results. The plot portfolio performance function shows the cumulative performance of the portfolio over time by computing cumulative returns of daily portfolio returns. It helps us see how the portfolio value has grown or shrunk over a given period of time. And this one visualizes the efficient frontier. We calculated that earlier. It's a curve showing the best possible portfolios for a range of risks or volatility. This creates a scatter plot comparing individual assets risk versus return. And in here, the Monte Carlo simulations that we calculated earlier are displayed as histograms. Lastly, this function plots the distribution of daily portfolio returns using a histogram with KDE, kernel density estimation. And the main file basically runs the entire thing cohesively with whatever query data is provided in the values file. And yeah, before we wrap up, you might have noticed the detailed, consistent documentation throughout the code base. Cursor played a significant role in transforming my rough notes into well-structured, meaningful documentation, all while maintaining context across the entire project. And that's it for this walkthrough. Developing this application has been an incredible journey into how AI tools can empower developers to tackle complex challenges while also saving time and boosting creativity. I hope this demonstration gave you insights into AI driven development and how it can redefine software engineering. Thank you for watching, and I look forward to your thoughts.